Hey there, welcome to the Energy Blueprint Podcast. I'm your host, Ari Whitten, and today I have with me Matt Maruca, who is a researcher, teacher, biohacker, and entrepreneur in the field of photobiology. He's the founder of Raw Optics, and he's extremely passionate about studying and teaching about the relevance of light and human health, which is also one of my personal favorite subjects. So I'm super excited to get into this podcast, and I know that Matt has some great topics lined up for us to discuss. So Matt, tell everybody about just how you got interested in this topic of light and human health in the first place.
Yeah. First of all, thanks for having me on. So when I was quite a bit younger than I am now, I was 14 years old, and I was really just looking into health because I was having a lot of struggles in high school, basically with gut issues, headaches, allergies, brain fog, fatigue, all the things that you teach about through your books, your podcast, your blogs and whatnot. I hadn't heard about, your work at the time. I'm not even sure if you had been publishing a lot at that time, but essentially I got into the paleo diet world because it was sort of a burgeoning, let's say, community which was attempting to address the root of the modern chronic diseases through food. So I did that, actually felt a ton better, but sort of hit some kind of, let's say, wall in the progress that I was making in, my overall journey. And I just kind of knew I could go further. That's when I learned about Dr. Jack Kruse, who I'm sure you're familiar with, big researcher on how light affects mitochondria and how mitochondrial function drives overall health in the body. I applied some of the protocols there and, started to really understand the idea that the way our mitochondria and our, cellular engines are working is actually so much more foundational to our health than the food that's the input into these mitochondria. So it just became my natural desire to learn as much as I could for myself. And then as a result, I found that I had accumulated so much knowledge that I'm able to, share. And I started my business based on the information I had learned and so on. And just kind of am rolling with it as it kind of comes.
Nice. So take me through sort of the big picture paradigm of your understanding of the interface of light and human health. And I'm writing a book on this. It's coming out later this year. I have my own kind of way of conceptualizing this. But I think the fundamental thing is that there's all kinds of layers to this story. There's all kinds of physiological mechanisms beyond just the story that most people are aware of, which is the vitamin D story.
Yeah.
And so I'm curious to hear how you conceptualize kind of that landscape of the interface of light and human health beyond the vitamin D aspect.
Yeah, it's a great question. So it's great timing because this morning I was writing copy for a project that I'm working on, and it happens to still be open on the same screen on the computer. So I'm actually just going to read off these few paragraphs just a couple short paragraphs I put together this morning because I spent probably 6 hours just thinking about the exact question that you just asked. So essentially, long story short, as it's written, not long ago, kids played outdoors. Since the development of screen technology, and by the way, I usually don't read stuff for podcasts, but it's just here, so I figured why not? Since the development of screen technology, kids now spend the majority of their playtime indoors, glued to cell phones, iPads, and TVs. For all of human history, likewise, the majority of adults lived and worked outdoors, constantly exposed to unfiltered, full-spectrum sunlight. Indoor living didn't exist. In order for matter to move, a force, that is energy, is required. The primary source of energy on Earth is sunlight. As a result, energy derived from sunlight powers the movement of all particles on Earth, all living organisms, and all of the development and advancement in living systems that has ever occurred. So that's worthy of repeat. But basically, light has powered and still powers not just all the weather patterns on Earth and the movement of all the molecules on Earth, but all of the advancement and development and innovation of all life as it exists today, including humans. So the next piece is all of the biological systems in humans developed under the power of unfiltered full spectrum sunlight, and our bodies still require constant exposure to the full spectrum of sunlight to function properly. So that's kind of the general idea. And then, the big change that I was sort of getting to here is, for the first time in human history, the Industrial Revolution brought people indoors for the majority of their days. The invention of the light bulb in 1879 allowed factories to extend working hours earlier in the morning and later in the evening, especially in winter when the days grew short. Standard time zones were developed to coordinate the schedules of the newly developed railway systems across England. Humans no longer slept and woke with the sun, but lived by artificial light. And the last piece is, as organisms with a majority of processes dependent on full spectrum sunlight to function optimally, the price of the shift to an indoor artificial light-based lifestyle was the beginning of an epidemic of never before seen diseases where, unlike infectious diseases of the past that would kill a human from the outside in, now the body slowly fails to carry out its own functions properly and fails from the inside out. So that is, the best I think I've ever put into a few paragraphs the way that I view these things. But again, just simply put, because that might have been a bit quick and scientific for some folks listening, and I recommend rewinding if someone has that issue, because it's really simply worded, I would say. I'm aiming for like elementary school understanding, although it's probably quite a bit higher than that. We literally, all living organisms developed and evolved under the power of the sun. And we have tons of, biological processes that are driven by the light. Obviously, you mentioned vitamin D as one primary well-known example. But for example, as you also, talk about, and others talk about, the importance of the red and infrared wavelengths on, for example, structuring water in our cells, driving improved ATP, synthesis in the mitochondria. Like, I think the best way to put what I'm saying is, there's the red light therapy devices that people are now adding, thinking they're giving themselves an additional benefit to their health, which they are. But the fact of the matter is that was sort of obligatory in a past world when we lived outdoors. And that's where we are supposed to be. So red light devices just bring us back to baseline in some sense. And even then they fall short because they lack the full spectrum that the sun contains. An expert, Dr. Alexander Wunsch, who I imagine you maybe even interviewed or at least familiar with, when I asked him, yeah, exactly. So he kind of explained to me how when we are in the sun, we can think of it almost like the way the light actually comes into our blood through, the veins in the back of our eyes and so on, because all of the blood in the body apparently is passing through the eyes every 40 minutes. The light's coming into our blood and it's actually able to, increase the rate of reaction of tons of different enzymes and reactions, like all the different wavelengths. I should say all the different biological processes and reactions are specifically enhanced by different wavelengths in that full spectrum. So if we're not in the light, at least for a period of our time, the reactions in our body are just much slower and more sluggish than they're designed to be. All of them, so many of which we're probably not even familiar with yet. But some that they do know about, is like the sex steroid hormones, the neurotransmitter function of the brain. These are all the processes of the breakdown of the precursors and then their catalyzation to the actual molecules like dopamine, serotonin is all sped up by the sun. So basically we're literally a being of light, and the sun is like a mega multivitamin that contains all these different wavelengths, all of which we need. So when people don't go in the sun, they're basically depriving themselves of a tremendous multivitamin that is absolutely critical for our function. And even if someone thinks they're healthy, they're probably not as healthy as they could be. And energized as they could be. But in general, very few people are really healthy without problems, without headaches, fatigue, gut issues, allergies, or something. Most people now past 30 or even past 20, oftentimes will have autoimmune diseases, cancer, and so on. I was getting that stuff when I was in high school. So that's sort of my take. It's absolutely critical, and we're totally destroying
not
ourselves.
Autoimmune disease and cancer, but you mean some of the other stuff like fatigue, brain fog.
Yeah, I didn't get autoimmune diseases and cancer. No, I mean, you could say that celiac is an autoimmune disease. So that's something that I basically have from a young age. So in a sense, yes, I fall into that category, but brain fog and so on. So, the gut issues were the things I was getting. I was getting some of the issues on the earlier of the train stops, if you will, of chronic disease. I didn't quite progress to the really serious issues, thank God, but that's sort of the overview as I see it at present.
Okay. There's a lot to unpack there. I want to come back to one of the things that you said kind of towards the beginning when you were reading what you had written, something to the effect of like how light is powering sort of progress of the animal species and including humans. And please correct me if I'm misrepresenting what you said there. But what do you mean by that?
Yeah, that's a really great question. So I'm glad we can unpack that one a little bit more. So for example, I've actually got this specific way of describing things from Dr. Douglas Wallace from the Children's Hospital of Philadelphia, big mitochondrial researcher, probably I'd say most important biological researcher of the decade, century, if not the millennium. He explained to me how, and in many of his videos does the same, where in order for life to exist, it requires energy. You're the energy blueprint and so on. So you're very well aware of that. And we want to make it better. The more energy life has, the better we can carry out all of our functions. The whole concept generally comes from Isaac Newton, at least the discovery of the concept comes from Isaac Newton, because in his classical laws of motion, he just described that in order for anything to move, it requires a force, and force is just a transfer of energy. And so for anything to move, it requires energy present. And if you look, in the example he often uses, Dr. Wallace, he'll say, if you look at a general environment, humans and other animals are the most animate thing that we can observe in the environment as far as movement, energy, and so on, besides animals, essentially. So obviously there's a lot of energy in us. Where is it coming from? And he even says it's actually coming from sunlight. Directly is something that him and other researchers are not so much focused on, but of course it's coming indirectly through photosynthesis, and then the energy being stored in the electrons of food. The point of that is that, if someone if you try to zoom out and imagine a picture of the earth as just a big rock, pretty much, we're moving a lot when you zoom in, so the energy for us to move is basically just striking from the sun, and through a variety of ways, the well-known again being indirectly through food, but less well-known being directly via skin and eye exposure to the sun. That powers our life and powers our function and that of all of living organisms. So to get, I guess, a little closer to the specific of your question, as far as the advancement and development of life, in order for life to reach the complexity that I currently stand in and that you currently stand in, there was, the merger, the endosymbiosis of the two different archaea and cyanobacteria that basically came together and created this, if you will, evolutionary power pack that was able to extremely complexify due to the, reduction of the genome of the cyanobacteria and concentration of that genome in the nucleus of the archaea, and then the, explosion of those cyanobacteria, which are now mitochondria within that cell, and not needing to use all of their energy to basically create and reproduce themselves, but able to basically give that to the greater host who's maintaining one copy, or I should say 2 copies for sexual reproduction of all of those genes. That massive extra abundance of energy of them not each individually having to take care of themselves, keeping all the genes in the one host nucleus, allowed for all that. But again, getting to the point of this is that for life to continue to drive forward, if life is aligned from the beginning of life to where we are now, the only way that we could ever become more complex isn't through, there is the Darwinist model, which says it's just random mutation, but that has been broken down in many, many ways by many different researchers and so on. And different, it basically falls apart when one understands that life is powered by energy. And so, yeah, we basically need that energy to evolve. And if we didn't have energy and then better ways of utilizing energy, we would have never been able to become more and more complex. So energy drives evolution forward and is necessary for more complexity. Better ways of utilizing energy are necessary for more complexity. And so the energy is still the ultimate root push there. And that's why I can confidently say that the sun, the primary source of the energy, is what allows life to drive forward in complexity and evolution. Does that kind of answer what you're?
Yeah, I get the gist of what you're saying. So, next layer to this is sunlight. You said, and I agree with this, of course, is that you said sunlight has a lot of different wavelengths that we're missing, that people are deficient in. And you've alluded to some of those that you've mentioned in passing, but give me the breakdown of what specific wavelengths are present in sunlight that are not present in most people's lives today because they're living mostly indoor lives, not getting sun. And so what are those wavelengths and what are they doing physiologically?
That's a great question. So the biggest wavelengths that everyone's deficient in are ultraviolet and infrared, because basically no modern lighting except incandescent and halogen bulbs include either of those. Incandescents and halogens at least include infrared. None of them include ultraviolet except party black lights, which some people will use to make everyone's white shirts glow in the dark at parties and clubs and discos and so on. So, but those are the only ultraviolet lights that
so
are
we need to
commonly
party under
today.
black. We need to do more black light
Yes,
parties.
absolutely. We should use black lights at parties and in our houses if we're indoors behind glass, just to make up. But so essentially ultraviolet, there's a good chunk of research in, again, this is sort of what Dr. Alexander Wunsch explains throughout his videos, for example, just on Vimeo. Anyone who's interested in further reading can look up Dr. Wunsch Vimeo. It's awesome. And essentially his focus is on the field of photoendocrinology in many ways. And in other words, how light drives the endocrine system and hormonal function. And what that really means is that specifically the ultraviolet wavelengths, through the stimulation of, our brain via our eye and the effects of the light on the hypothalamus in that sense, essentially leads to the increased catalyzation of the reactions that create things like tyrosine into dopamine. Create tyrosine, turn tyrosine into dopamine. For example, also take tryptophan and turn it into serotonin and then melatonin. Just ultraviolet light being present on the body, in particular on the eyes, accelerates the conversion of these molecules, is the way that he teaches it. So that's one piece that is fairly well studied. The same goes for the production of, for example, alpha MSH from exposure to sunlight, and from there other endorphins, such as beta endorphin, being a natural, let's say, painkiller and tremendous. It's like an opiate, basically endogenously produced in its structure, that we get just from being in the sun. So the question that would behoove people to ask is, if ultraviolet light causes cancer, why is our body producing opiates essentially within us to provide a massive, amazing endorphin rush when we are bathing in the sun? Logically, it would lead one to believe that there is some huge benefit and the body actually wants to get in the sun. And of course, there's mechanisms to stop when we get too much. Like I was out in the sun this morning, again, later in the day, I'll be back in the afternoon in the sun again. Like when I got enough, I know when I've gotten enough, especially because I'm in Mexico and it's a bit stronger here than it ever would have been in Ireland and England, where my ancestors come from, quite a bit stronger. Except, for maybe the 2 or 3 months in the summer, they would have had strong sun. So ultraviolet has a huge role in photoendocrinology in that sense of hormones and neurotransmitter function. And that's pretty critical. Other things that ultraviolet does via the skin is the synthesis, or I should say, stimulates the release of nitric oxide. And the way that for example, Dr. Wunsch does describe it is, when ultraviolet light hits the skin, it leads to the release of this nitric oxide, which causes blood to flow more freely throughout the cells and so on, throughout, I should say, the veins and the vessels. And then this often, or what it leads to, is dermal pooling, which again, I imagine you're familiar with, the blood coming to the surface of the skin. And then blood contains on the hemoglobin molecule, the hemoglobin protein, I should say, on red blood cells, is essentially a very, very well calibrated light receptor that has absorption peaks in the red and ultraviolet range. So basically our blood and our blood cells have been shown to have absorption peaks, again, in ultraviolet, but also red and infrared, meaning that our blood desires the light too, and ferries the light essentially through our blood to our mitochondria along with oxygen. And this essentially improves the function of our mitochondria in many different ways. So that's sort of a bit of a touch on what ultraviolet is able to do. And of course, there's the well-known example, vitamin D synthesis. On the other side of things, anyone who's read your book and your work, I think you might be muted. Of course. So yeah, anyone who's read your book knows about the, effects of red light on mitochondrial function and a huge, tremendous amount of other functions. And our modern lighting does often have red, but then there's infrared, which also has a huge impact on the water in the body, structuring.
Let me interrupt just for
Please
1 second. I want to jump back to UV before we get into red and near infrared.
Let's do that.
I like how you outline the mechanisms there. I think you did an excellent job because there's a bunch of layers to the story as you outlined beyond just vitamin D that we know are linked with various health benefits. Now, some of the arguments, the logic you're using is sort of, and to be clear, I don't disagree with it, but
you can disagree anyhow.
More naturalistic logic that appeals to people who come from a naturalistic paradigm, which I would include both you and I. But it's sort of like, well, we can look at the fact that our cells have are designed to absorb or happen to absorb specific wavelengths of light in these frequencies, in these wavelengths. We can look at the fact that our bodies actually produce beta endorphin, as you pointed out, that creates this this pleasant sensation, this pain-killing, opiate-like blissful sensation. And the fact that humans are sun-seeking, like people like going out into the sun and sun tanning, and it feels good. And so you can make these kind of very basic common sense observations. And from that level of common sense of the very fact that people like going out in the sun and it feels good to sunbathe, to the fact that we know clear mechanisms of why some of that takes place, from beta endorphin and how that affects the brain and creates these kind of feel good effect. But let's say somebody was not coming from a naturalistic paradigm. They're not convinced with this sort of logic. They say, oh, it's just a coincidence that, our bodies happen to make endorphins and it happens to feel good to lay in the sun. But really, we know from these lines of research that ultraviolet radiation is toxic to the skin and causes skin cancer. And therefore, you should stay out of the sun.
Yeah.
What would you say is the actual, as it not appeals to sort of a naturalistic paradigm, but what is the actual evidence to support the benefits of sun exposure? And we can talk about the skin cancer thing specifically if you feel comfortable to get into
Absolutely. Yeah, I would love to. So let's start with, let's unpack that properly. So my goal, first of all, by the way, please freely disagree, because I know you're one of the few people who I've done an interview with who could very well know more than I do about many of these different things. So please do not hesitate to hold back and jump in and disagree at any point.
I won't. If you say something I really disagree with, I
please do.
I will point it out.
Correct me, because I do not know everything. Just to be clear, like no one does. But so that's a really great point, because I do lean more towards that naturalistic perspective, just because of the way that I already have come to believe these things through the research I've done and then my own personal experience. But I appreciate you bringing that up. So I would be inclined to start with just discussing, again, a step back to where we were about how life requires energy to function. The primary and dominant by far source of light or energy on Earth to drive life is light. And so therefore, from a basic scientific perspective, it's very hard for someone who is not naturalistic by any inclination to disagree with the fact that if the sun didn't come up tomorrow, everything's going to die. In other words, not right away, but over time, everything will die. Because
so there are people who, I mean, in the scientific community, there are health professionals in particular. There's like dermatological associations that are advocates of sun avoidance for humans, and so they're obviously not convinced by these naturalistic arguments, and they might even say, plants will die, and therefore humans might suffer as a result of plants suffering from lack of sun exposure. But humans don't need sun exposure, and the sun exposure is harmful to us. So what would you say is the counter?
I'm glad. Yeah, let's get straight to the point then. So the best example that's really impossible or very challenging to argue with is vitamin D. So except for cultures that consume adequate and large amounts of vitamin D from their diet, which would be primarily, seafood based cultures, Nordic, for example, Europeans would be a good example of that. Besides them, people living in the tropics and other places on the world, their diets are either wholly deficient or very low in natural sources of vitamin D, but yet it is absolutely essential for a tremendous number of biological functions, probably more of which you could list than I can, but one being proper immune function, along with proper bone function, development, and many others. If sunlight is bad for us, why would such an essential hormone be completely dependent on ultraviolet exposure in order to be synthesized?
Because evolution knew that eventually humans would create vitamin D supplements and have no need for sun exposure.
Exactly. Thank you. Thank you. So that's probably the best way to start, for the most rigid by the book, person you might speak with who just says absolutely not a chance. Could the sun be in any way necessary directly to the body beyond indirectly via food consumption?
Okay. So let's say someone's still not convinced. You got a dermatologist saying, no, but we have these studies showing that ultraviolet radiation causes skin cancer. And therefore, even if we have a need for, we've evolved a need for vitamin D from sun exposure, we also know that getting that sun exposure increases your risk of skin cancer.
Yeah, that's a great question as well. So there is evidence,
And to everybody listening, to be clear, this is not my perspective. I'm just playing devil's advocate.
This makes for a really great interview. It really does. I'm very grateful for this, actually. So, for example, looking at certain studies, there are studies. Let's just be clear. There are clinical studies, and keeping in mind that no clinical studies are perfect, that do show that increased or that sunlight exposure is linked to the development of certain skin cancers. So just to be clear, I'm not denying that there is research showing that. And we have to just sort of look at, okay, what could have led them to find that in those studies? And does that mean that sun's entirely bad, or is it the context in the studies and whatnot? So some research that I can recount is that people who get melanoma, for example, people who contract melanoma, malignant melanoma, skin cancer, very, damaging and risky type of skin cancer for those who aren't familiar with it, which is generally attributed to sun exposure. There's many people who get melanoma, like an aunt of mine actually, who get very little sun exposure. So just to be clear, that's one type. There are people who get melanoma who also have a good amount of sun exposure. So there's some studies that show, and I don't have the exact name in my mind, but we can get these sent over later on. Anyhow, if you want to link them, but basically that researchers, or I should say, individuals.
I'll mention quickly for anybody who wants a good source of research. This book called "Embrace the Sun" is by Mark Sorensen and William Grant. Dr. Mark Sorensen and Dr. William Grant is probably the best compilation of research on the relation on sunlight and various diseases, including melanoma. They have a big chapter. Actually, the first chapter of the book is on melanoma. So if you actually want to explore like a rigorous analysis of all the science on the subject, that's a really good source for anybody interested. But I think there's lots of research there backing up what you were about to say.
Yeah, of course. Well, honestly, I bet there's more in that book. I'm actually going to pick that up because I haven't come across it until just now. But essentially, long story short, the people who contract melanoma who have exposure to sun actually have a higher survival rate, significantly higher survival rate than those who do not have exposure to sunlight. And so that, again, the scientists were in some way, I guess you could say, confused, because if sun causes the melanoma, then why would the people who get the melanoma and get sun exposure have a higher survival rate, significantly higher survival rate? And, some of the potential explanations there are increased levels of vitamin D, improved immune function, improved ability to kill and take out bad and harmful cells in the body. And that was sort of the explanation. So that's one piece of information, that one could consider regarding this. Now, because you're asking from a clinical perspective, we can talk about some studies that I'm actually fairly familiar with. There's one by a guy named Lindqvist, who's a Swedish researcher who did a study over a lifetime on a cohort of 20,000 Swedish females. and was evaluating basically what are the factors that affect all-cause mortality. So basically deaths by various causes, whether it's old age, disease. Most of people dying today are dying from actual chronic diseases and not old age anymore. But they found that the number one risk, or the number one factor leading to an increase in mortality from all different variable causes of death, is avoidance of sun exposure. So this is a very well-controlled study over a lifetime of these women. And they found that it is so significant that it was even more significant than smoking cigarettes. Avoiding sunlight, essentially the conclusion that is drawn and can be drawn is that avoiding sunlight is the same magnitude or even greater magnitude risk to the body of smoking cigarettes on a regular basis. So avoiding sun and not getting sun in studies, clinical studies, is as damaging or more damaging than smoking cigarettes. So just to be clear, that's one really great study and piece of data. And again, no study's perfect, but we're, very well controlled and done over a long period of time with a huge sample size to be able to see, okay, well, maybe the sun is significant because they looked at all, the chemicals they're exposed to, what they do for a living, their stress levels. I mean, everything you can evaluate in one's life, essentially. Quite a few number of factors anyhow. So that's a really great study on the subject.
I'll interject some stuff here. I like shifting to the bigger picture context as you did there. I think it's really important to look at all-cause mortality. In this whole picture, I think that the really by far the most meaningful thing, and you maybe could even argue the only meaningful thing, is to look at all-cause mortality. What is the overall net effect, figuring into account all mechanisms, all potential diseases that are increased or decreased risk in relation to sun exposure? What is the end net effect? Does sun exposure lead to longer lives and less disease overall, or does it lead to shorter lives and more disease? And that Swedish study that you mentioned is a really great example showing that regular sun exposure is very clearly linked with longer life and lower risk of numerous diseases. But just to get back in the melanoma issue, and this is something I've been writing about in recent weeks, and it's a complex topic where, as I mentioned, dermatological associations have come out and they use various studies that say, there's all kinds of studies where they look at isolated ultraviolet light, on petri dishes with cell cultures or on animals. And things like that. And you absolutely can take isolated ultraviolet light and shine it on cells and induce DNA damage and tumor formation. And those mechanisms are even well studied. And there's a very clear mechanism of action by which this can occur. And even there's research in humans linking frequency of sunburns, past history of sunburns, to increased risk of melanoma later in life. And there's research linking intermittent sun exposure, which is basically like somebody who gets sun exposure infrequently or irregularly.
Yeah, the weekend warrior,
Right. Or somebody who is an indoor office worker or lives in a place where they don't get much sun, and then occasionally they go on a vacation where they get tons of sun exposure. Okay. So sunburns and intermittent sun exposure very clearly linked with increased risk of malignant melanoma. And so taking into account all of those layers of evidence, that's what these dermatological experts are basically saying, hey, we have clear evidence from a mechanistic level to even a human level showing that sunburns and intermittent sun exposure are linked with increased risk of melanoma. So stay out of the sun. On the other hand, there's studies, and I would argue this is the best kind of study to really assess whether sun exposure is or is not linked with melanoma, or to what extent it is and what way it is. Comparing indoor workers to outdoor workers. Outdoor workers get 3 to 10 times more exposure to sunlight than indoor office workers. And obviously, if that's the case, if sunlight is causing cancer, you would expect to see massively increased rates of melanoma in the outdoor workers compared to indoor workers.
Thank you for sharing this.
And in fact, we don't see that. And there's several studies that have looked into this, and the vast majority of them find either no increase whatsoever in outdoor workers in melanoma rates, and several of those studies have actually shown massively reduced rates of melanoma in outdoor workers. So while sunburns and intermittent sun exposure are linked with increased risk of melanoma, it is also the case that regular, frequent sun exposure below the threshold of sunburning, where you can engage your body's natural adaptive mechanisms, melanin in particular, that to build a tan, to decrease the body's or to increase the body's resilience to UV exposure and decrease or eliminate DNA damage from ultraviolet light exposure. By doing that regular, frequent sun exposure, you do not have an increased risk from the best studies. And again, this book, Embrace the Sun, outlines all of these studies I'm referring to very, very in depth. But the regular, frequent sun exposure is not linked with increased risk of malignant melanoma. In fact, best evidence indicates that it's linked with decreased risk. So how you get sun exposure matters. And whether you are, living in England and then occasionally you go to Hawaii or the Canary Islands or wherever and you bake in the sun all day and end up fried, that's not a good pattern of sun exposure. It's like being sedentary all the time and then once a month or once every couple of months you go run a marathon.
Yeah.
That's not a pattern of exercise that's going to lead to health benefits. And in the same way you need regularity and frequency and proper dosing of exercise to get health benefits, the same is true of sun exposure. If you do it irregularly in massive doses, not a good idea, but regular, frequent sun exposure below the threshold of sunburning is absolutely healthful and is not linked with skin cancer.
Absolutely. And that is very, very well put. I'm glad you've shared those pieces. It didn't even come to my mind when you asked the questions, the research on the indoor versus outdoor workers, but I have read quite a decent number of, or pieces of research there. And it's very, very compelling to, even a skeptic, I would say, at least it's very challenging to challenge or to completely tear apart. So that's very, very spot on the money there. What keeps coming up as you're describing these things in my mind is the research regarding biophotons. Are you familiar with biophotons and so on?
Yeah, I'm familiar with it. To be honest, I haven't dug into the biophoton stuff so much because I'm kind of under the impression that it's like, yeah, we know they're there and they do something, but we don't really understand them that well.
That's accurate, I would say, very accurate. There's a really good textbook on the subject called Light Shaping Life, Biophotons in Biology and Medicine, which maybe you've read. It's just a compilation of basically the majority of the data up until the early 2000s, basically from Russia and Germany, but Russia in particular. Researchers were essentially looking at cells, and they were using these photomultiplier devices that were designed in order to be able to detect these really small amounts of light. And one of the most amazing findings that I recall from the research there is that the stimulus for cell division is small pulses of extreme low frequency ultraviolet light. So,
oh wow, emitted by the cells.
Emitted by the cells. The biophotons most commonly measured in their experiments were all ultraviolet. So just and that's one. I mean, there's other observations I can get into a little bit, but just starting there, if ultraviolet is absolutely cancer causing, why would it be, again, this is taking a little bit of a naturalistic perspective, but I'll still throw it out anyway. If ultraviolet causes cancer, why is it that our cells are using ultraviolet wavelengths for communication and signaling? That doesn't quite add up if it's this horrible thing. So again, putting it in the context that you just described, huge amounts of excessive ultraviolet doses at the wrong time of day, the wrong time of year, and so on, could very well be disruptive to the body's functions, especially if someone hasn't built a proper solar callus, which is our natural mechanism to protect from that. But saying that ultraviolet causes cancer is like saying that oxygen causes cancer, because you can observe that cells that have cancer, they're using up a lot of oxygen, for example. I'm not an expert on cancer, but there's, if I'm not mistaken, cancerous cells typically use quite a bit of oxygen. My apologies. They're in a more anaerobic metabolism, but there's a lot of oxidative stress and things going on in cancerous states and the general disease states. And so you could say, oh, well, because, in order to generate free radicals, those are generated through oxidative metabolism, which is of course using oxygen. Therefore, oxygen must be, causing these cancers. Like you could say that, but it doesn't really hold up to the test of time. But that's because there's now a whole massive industry of sunglasses, dermatology, and sunscreen. They have that sort of pull where they can just say, oh, this is bad, and diminish any research against it. And it does become challenging for the information to get out to a larger audience, even if the science is more solid. So anyhow, that's one piece of research on biophotons that's very fascinating. Other bits and pieces are that sick cells they were measuring, cells that were basically, I presume, extracted from a diseased state, whether it was an animal or whatnot. They're leaking higher amounts of these biophotons. In other words, higher biophoton emission versus cells that were healthy, determined to be healthier, were leaking less, essentially. So they were retaining more biophotons. So again, the research hasn't been replicated as much as it should be going into the modern times. It also hasn't been analyzed as very much since it was first done by these various researchers, the biggest being Alexander Gurwitch from Russia and Fritz Albert Popp from Germany. But nonetheless, it's pretty solid on these things. And then one of the most fascinating things that was described in that book is that that when an organism died, the organisms they were experimenting, or the cells, they would actually leak all of their light for quite a long, presumably all of their light. They would leak until they wouldn't leak anymore. So that was something like 18 hours of leaking that was going on. And the thing that struck me so much about that is there's so many, again, this is where we get into a naturalistic or even woo-woo territory for some, but there are so many spiritual disciplines, Christianity, Buddhism, Hinduism, that describe the departure of the soul from the body. The soul, which they claim to know is made of light, departing from the body upon death. And it just kind of struck a chord that was all too coincidental for me when reading this, that maybe there is some actual physical scientific basis behind these 5,000-year-old beliefs. And anyone who's, Christian or religious or spiritual would probably say, oh, that makes sense, actually. But of course, someone who's very atheistic will say, oh, well, that light doesn't matter and the soul is totally separate. Anyway, that's just what the evidence at present shows on the biophoton research. So, take it or leave it, but that's part of the deal. Yeah. So that's what the research is showing about biophotons and so on. So given that, again, anyone can say, oh, but there's not enough studies, there's not enough replication. There's quite a bit of research if anyone wants to pick up that book, and lots of replication, peer-reviewed data. Nonetheless, to claim that ultraviolet is causing cancer and is inherently bad for biologic organisms is just basically showing ignorance of what the data is. And anyone who's at least aware of that data would be with the scientific mind would be obliged to at least say, okay, well, there's some studies showing that ultraviolet could cause cancer and other things, even if they're often very isolated. And then there's this research showing ultraviolet's so foundational for cellular signaling in the biophotons, which are, again, tiny, tiny amounts of light that don't, at least as they were measured, don't even compare to how much we're getting struck from the sun by. But why would it be, why would this be the case? How could we reconcile these things rather than just saying, oh, ultraviolet's the worst thing ever and inherently bad, So that's one piece that just comes right up as you describe the melanoma and so on there.
Yeah. Now let's talk about some of the other layers to this. So many. I know you wanted to get into red and near infrared, and I kind of interrupted. We can
talk about ultraviolet a little bit more if you don't mind. I mean,
yeah,
I love
sure.
ultraviolet.
If you've got more to say.
Yeah, absolutely. Well, so what also comes up is the research from the early 1900s. I mean, forget about the stuff from even further back. Actually, why not just briefly touch on it? This is an anecdote from long, long ago, but at the Battle of Pelusium in, I believe, Carthage, way back when. This was thousands of years ago. So scientifically doesn't hold much weight, but just from a story, the Herodotus, who was the Greek historian who went and examined the battlefield after the battle, noticed a distinct difference in the strength of the skulls as he would hit them with the rocks, just to test them. The skulls of the Persians, who were known to wear caps and so on and lots of clothing, their skulls literally shattered with just the tap of a pebble, whereas the skulls of the Egyptians, who were generally known to shave their heads to allow the light to hit their skull more directly, had skulls that could not be broken. Again, it's an anecdote, but it sort of does preface well the more modern understanding that vitamin D, which is, for proper assimilation and usage, is required to come directly from the sun and the ultraviolet range of light, UVB, of course, in particular. So there's some definite, historical evidence behind the sun and the cultures that, were in the sun versus those that weren't in their physical structure. Fast forwarding, for example, there's other documented research, and I should say observations at this point, from Florence Nightingale, the very well-known nurse and basically pioneer of hospitals and healthy practicing and in the medical world. And one of the things she noted on several occasions is that patients who were in dark wards of the hospitals would often either heal very, very slowly or not at all, oftentimes. And compared to those in wards where lots of light was coming in, would do much better and have significantly better outcomes. That could very likely be attributed to the impact of sunlight, in particular ultraviolet, and its ability to kill bacteria that can be harmful in a hospital, but also the effects on the body, the circadian rhythm, which is something we can get into if we want to touch on the blue component of the spectrum and the green. Anyhow, more recently in the early 1900s, there were the biggest probably development was when Niels Finsen discovered that red light is beneficial for healing cells and ultraviolet is absolutely critical for maintaining bacteria-free living. In other words, being exposed to sun kills bacteria because bacteria don't have the skin and cell membranes that we eukaryotes have that are designed to be exposed to sun, generally speaking. So ultraviolet's bactericidal in general. And so he found that the cure for tuberculosis of the skin, which was known as lupus vulgaris, or is known as lupus vulgaris, was just exposure to ultraviolet light. So in one way of interpreting that would be to basically say the people who lived in dark places where they stopped getting sun, as we had for a really long time, the people who were in the Industrial Revolution, now basically indoors all the time, in a world where sanitation wasn't good, there were no vaccines. I'm not saying I'm a fan of vaccines, but there's none of these practices today that do seem to have reduced our, the infectious diseases significantly. The people who went indoors and avoided sun, they got serious outbreaks of toxic bacteria that would kill them and completely disfigure their face and their body, if not. So they shined ultraviolet lights onto these people's skin and it would heal them from this tuberculosis. But internally, because that's an external offender, so the skeptic could say, well, that's just a coincidence. Internally, he also, and him and his contemporaries, observed that children who worked indoors in factories developed rickets. And again, that is a function of ultraviolet light creating vitamin D to allow calcium to build our bones properly. Children who didn't get any sunlight, their bones were basically totally deformed. And so they would use ultraviolet and concentrate it through lenses onto these children, and their rickets over time would basically fade away and disappear. And then from there, this was Niels Finsen, and it was the first actual Scandinavian, interestingly enough, to ever win a Nobel Prize in medicine, was this guy for his discovery about tuberculosis of the skin and curing with ultraviolet light. So then getting into the later 1910s and 20s were the heliotherapists of Switzerland. There's particularly Auguste Rollier, the French-Swiss guy, who essentially he had dozens of clinics at the peak in the Alps, where they would literally, for the sickest patients, they would roll them into the sun on south-facing hospitals built in the mountains onto these terraces. They would roll their feet and do 5 minutes on the feet and then back in the shade, and then 5 minutes on the feet, 5 minutes on the thigh, and I should say 10 minutes on the feet and 5 minutes additionally on the thigh. And they would just build it up like that, where then the feet would have 15, the thigh would have 10, the upper leg then, I should say, not the thigh, but the calf, then the thigh would have 5. And they would just build all the way up the torso into the face until.
And just to be clear, you don't mean in the course of one individual day's.
This was one day
over the
at a
course
time.
of days and weeks.
Exactly. So one day at a time, literally, it was just for anyone who's the sickest and palest person who can't get tan. You do 5 minutes on your feet, off, then do 5 minutes on your feet and your lower leg, and then roll back and just 5 minutes on your feet, and then done again. And they would build up the whole body that way and take the sickest people. And just to name some of the diseases they would treat were rickets, of course, tuberculosis, but they would also treat wounds from World War I soldiers, and wounds were found to heal significantly more quickly with exposure to the sun. Such that the Germans in World War I also had tons of clinics and used the sun to heal their wounds in the wars. And so it just begs the question in a sense, even if it wasn't deeply researched exactly why it was working at that time, although they knew that it was working, what is, there's so much behind this. If it's artifact, if it's coming from something else, what is it? Like, how is the sun driving improvement of so many biological systems so thoroughly across the board that, it's just, and of course one of the biggest killers was, of course, getting a little later on in the 30s and whatnot. There was research starting to come out, as you mentioned, about cancer and sunlight causing skin cancer, because there was actually a craze in the between 1900 and 1930 in the United States, like sunbathing. There are cartoons people could look into. There's actually a really great paper called The Evolution of Popular Attitudes Towards Sunbathing, something like that. It's 3 parts, and it is presenting a more why the sun does cause skin cancer perspective. They believe that is the case, but they have all these cool cartoons from the early 1900s of, like, for example, a cartoon on a beach where everyone was totally nude sunbathing and one person was clothed or clad, I should say, and everyone was laughing at that person. It was like sunbathing was popular. Almost probably to an extent where it became too much, and that could very well be why there started to be some interest in the skin cancer properties. But anyway, stepping aside, well, we could touch on how some of the studies showing ultraviolet causing cancer were done on animals, where they would absolutely obliterate their eyes and their skin with what would be today studies that wouldn't be allowed because they were so abusive. They would literally cook the animals with ultraviolet light from an artificial source, not the sun, unbalanced by the red, infrared, the circadian fluctuation in the light, and so on. None of that. It was just pure UV overdose.
It's sort of, when you isolate things from their natural context, it's like, the way I like to think about it is like, imagine if you isolated just the sugar from blueberries and you gave that sugar in really high doses to people. And you found that sugar, fructose, causes all kinds of harms, all kinds of harm. Yeah, of cancer, many other diseases. There's numerous diseases linked with excess sugar consumption, refined sugar consumption. And then once you found that out, that refined sugar consumption is linked with all these diseases, then you concluded blueberries are harmful. You must avoid blueberries because they contain sugar.
They cause cancer, just to be specific.
Right. So it's sort of like what many people have done with the sun is, like, you instead of giving people natural sun exposure in a proper context with all of the other wavelengths that balance it out, it's like, let's isolate this one component of ultraviolet wavelengths, expose cells or animals to that in unnaturally high doses. Again, without the wavelengths, especially the reds and near infrareds that counterbalance. And then you cause DNA damage, and then you conclude, sunlight is harmful and causes skin cancer. And that's an oversimplification of the argument. As I mentioned before, there's some other layers to the story, but that is a big part of what the argument has been based on. Yeah,
absolutely. And so I appreciate you giving that perspective. It is really well thought through, and I hope you include that in your book, actually. That's great. So, and then of course, to kind of close off that piece of the story with ultraviolet, around World War II, of course, antibiotics were developed. And so now they didn't need the sun to cure tuberculosis anymore, because you could take a pill that would just absolutely destroy all of the bacteria in the body, part of which are the mitochondria. So antibiotics are also horrible for the mitochondrial function based on some stuff I've seen. But again, that's, requires more research, but nonetheless, it's just from there, with the research as it stood, sunlight causes skin cancer, UVs causes cancer and skin cancer, avoid it. I think we sort of fell back into a period of the dark ages where people, many people would still be rebellious and suntan without sunscreen because they just wanted to. But even me, when I was born and growing up, I was totally sold on the concept that I need to wear sunscreen. And I was the only one of my friends who was like, guys, you got to put on the sunscreen. You're going to get cancer. I put on so much sunscreen. It was crazy because I was so pale and I would burn. As soon as I started changing my sun exposure and my daily habits, such as, getting to sleep earlier, getting up and getting the early morning sun exposure to sort of precondition my skin and reset my circadian rhythm and not go out in the middle of the day only to cook myself, but really focusing on the early morning hours that have more red and infrared and less UV, I actually started gaining such tremendous health benefits. And I was able to develop an amazing tan, which I never would have imagined possible in a million years. Where there's so many people today who say, I can't tan, I just burn. That was me. You're not, condemned to that forever. So,
and there is, to be fair, there's truth to skin types, but you are if you're not Fitzpatrick skin type 1, you're probably 2. But
I'm a 1. I think.
You're Irish and English ancestry, so you're among the skin types that are least conducive to tanning and have the lowest tolerance to sun exposure. So if even you can develop a tan with proper sun exposure, then that's a good sign that pretty much anyone can. I'm a little bit more blessed in that department, in that I have a lot of Mediterranean ancestry and North African ancestry and things like that.
That's
Italian
great.
and kind of the whole rim around the whole Mediterranean region. So I develop a tan pretty easily in the summer.
That's great. I actually would add, I'm in a way glad that I have this ancestry that I do because, for example, if I am confined to a place such as Northern Europe or North America where there is low sun for quite a long period of time, I am able to assimilate more light than if I did have darker skin.
Yes.
And that is something that's very hard, maybe a touchy subject to address because it brings in race and skin type and all this stuff. But biologically, the government in its recommendations about sun exposure entirely ignores differences in biological skin color. And so one thing that people don't know, which again, some people will hate me just for saying this, but is that people with darker skin take longer to make vitamin D, 3 to 5 times longer, depending on,
I don't think anybody's going to hate you. That's a fact. And I mean, it's okay to talk about facts of physiology that relate to how much melanin is in the skin.
Of course. Yeah. Thank you for clarifying there.
Without being a racist.
Yeah,
I don't think you have anything to worry about. But good. Yeah, I mean, as you said, it's also a blessing for people who live in, let's say, Ireland or England to have more of your skin type because you can create more vitamin D than someone like I can.
Exactly.
In a very low sun exposure environment. Interesting fun fact, people who are redheads from, for example, Irish ancestry, have an entirely different type of melanin. So, and I don't know if you necessarily have that, Matt.
Yeah, I'm purely blonde.
Okay. But I mean, this is a fun fact that kind of blows people's minds. But my skin type is actually closer to a black person from Africa than it is to a redhead from Ireland, because a redhead from Ireland actually has an entirely different type of melanin in their skin, whereas I have the same type of melanin as a black person from Africa. They just have more of it than I do.
Yeah. The redhead's an amazing innovation of biology, Yeah. It's pretty funny, but it's amazing how we adapt so well. So, another anecdote, if you will, or biological, historical observation based on what you just said that comes to mind is why would, as we went further north from the equator, why would skin have gotten lighter? At least in Europe, the adaptation was innovated. It wasn't innovated in Asia and among the North Americans, North American, Native Americans or Indians, they sometimes say, but it was at least innovated in Europe. Why would it have been innovated? If sun was bad for us, why would we be innovating, or not necessary biologically? Why would we have innovated this lighter skin tone? leaving it just purely at that, why, what's the purpose? Could they explain? Again, one might just say, oh, it's just artifact, it's just from another thing, but really,
Mm-hmm. The last topic I want to cover with you, and this is a big one, and I'm going to ask you to treat it very briefly. So hopefully you can do justice to it. This is a challenge, but hopefully you can do justice to this topic in a short amount of time. But we have about 10 minutes left, and we haven't touched the whole topic of circadian rhythm or artificial light at night yet. So can you talk a bit about, big picture, if you can do in under 10 minutes, a summary of that whole topic?
I'll do as briefly as possible so we can close off without a rush. But one of the other wavelengths in the sun that controls a different biological system are the blue component. Best way for someone to consider this is that when the sun rises, the reason it has less blue and more of the other colors, and that therefore appears more orange or even red sometimes, is because coming from that angle of the horizon, the light has to pass through much more atmosphere, and higher energy wavelengths such as blue and violet are filtered out when they're passing through more atmosphere, more than the lower energy wavelengths. Just like wolves running through a forest in a pack, the ones running faster might hit a tree and be scattered, which is what happens with these molecules in the air. The ones moving slower can bob and weave a little bit better. So anyhow, as the light rises though and comes through less atmosphere, the blue content obviously changes, as does the ultraviolet and violet, very significantly. And so it makes sense biologically that we would have selected specifically the blue color because there's so much of it in the sun proportionately as it relates to our ocular perception of what we call blue. We would pick that as that range that we're going to use to know that the day is beginning. And naturally, great way to say it is we need to biologically be ready for day, because the circumstances of day when we're active and hunting and fishing and gathering energy are significantly different than the requirements of night when we're sleeping and regenerating. So the same goes for the end of the day. When it gets dark, the light declines and the blue component declines quite significantly, and there is a little increase in blue proportionally just at the last light of the day. But anyhow, and that stimulates, again, the production of melatonin. So in the morning, it's the wake up, cortisol and other hormones. In the evening, we create melatonin, which helps us sleep. So that's the basic circadian rhythm, essentially. There's many other pieces that occur throughout the day with various hormonal secretions, and throughout the night, like human growth hormone is secreted at the right time if our circadian rhythm is working in proper function. Nonetheless, that's how it essentially works, and it just runs 24 hours and it's set by light in the morning. So if we're exposed to artificial man-made blue light during the day, it's stagnant, it's not fluctuating. That has certain effects on our body, especially because that light isn't balanced properly. Just like we discussed earlier, it's isolated, primarily the blue, it's lacking ultraviolet, it's lacking infrared, and it often includes flicker present in artificial lights due to the power grid, which stresses the brain further. Anyway, though, the key is when we get that artificial blue wavelengths at night, it phase shifts our circadian rhythm, I should say, essentially forward. So the brain is now being taught to sort of wake up again once the sun goes down, and the secretion of melatonin is delayed. And the reason that's a really big deal as it comes to the modern chronic diseases we're facing is because the majority of modern chronic diseases have been shown to be mitochondrial in their origin by Dr. Wallace of the Children's Hospital of Philadelphia. Specifically, increases in mitochondrial DNA mutation called heteroplasmy rates is constantly seen across all of these chronic diseases. So that being said, at night, that secretion of melatonin is the time in the day when we repair that oxidative damage in mitochondria and repair the mitochondrial DNA. If we have blue light after the sun goes down from any light source, screens, LEDs, fluorescent lights, whatever it may be, we're suppressing the secretion of melatonin, which is also suppressed if we don't get our morning sunlight exposure, which helps catalyze the formation of melatonin and or serotonin, the precursor to melatonin, and so on. So we need both morning sun and absence of sun or light in the evening for proper melatonin. But anyway, lowered melatonin leads to increased mitochondrial oxidative damage and DNA mutation, which leads to increased rates of all of the chronic diseases we're seeing today. And so it's a really big issue, like really mega big. Anytime you destroy sleep, it's linked to every big disease. And so that's the gist.
Yeah, well done. And I will say not a lot of people, even people who have dug into the research on circadian rhythm a bit, not a lot of people have uncovered this relationship of melatonin and mitochondria specifically. And I think that, and I agree with you that it's a really important layer to the story of human health and disease prevention. And of course, energy production.
Yeah, absolutely.
With overcoming fatigue and optimizing your mitochondria for producing optimal amounts of energy. If you are suppressing your melatonin levels each night through artificial light exposure and lack, and I'm glad you tied this also into the daytime light exposure, which is another piece of the puzzle when it comes to how much melatonin we're producing. But when you suppress that melatonin surge that you get every night by upwards of 50%, as it's been shown in research that even standard room lighting does, what happens when you suppress by 50% this hormone that is not only involved in sleep quality, but is a powerful hormone involved in prevention of numerous diseases, especially cancer. There's a whole bunch of research on melatonin being an anti-cancer compound, but this powerful compound that protects your mitochondria and keeps them healthy every night while you sleep. So if you suppress by 50+% every night for months and years and decades, this levels of this anti-cancer pro-mitochondria hormone, do you think that that's eventually going to have some consequences? And of course
Well
it has
put.
massive consequences. Yeah. So wrap up, I want to ask you, what are your top 3 kind of quick, off the top of your head, quick strategies that you want to leave people with on a practical level, quick strategies to use light to benefit their health or to manipulate light exposure?
Absolutely. So one would be, and I call this the light diet. There's a whole set of steps that I'll be releasing over the next few months in various interviews and so on. But so one would be wearing blue light blocking glasses in the evening and going to sleep quite early, before 8 or 9, but specifically picking the time so that you wake up naturally before the sun comes up in the morning. And it'll take some time to get that adjustment. Maybe you have to use an alarm if you're sleeping way too long, but do that one. That's step 1. 2, then do actually wake up in the morning and go look at the sunrise when it comes over the horizon. The ancient Indians or Ayurvedic people call this sun gazing. It can be safely done looking right into the sun for the first 15 to 20 minutes, depending on where you are on the planet. Some places it's longer if you're further away from the sun. Doing that, and that's going to basically be the fastest, quickest way to reset the circadian rhythm. And then as you develop, start to build in some later morning sun exposure to help build up the ultraviolet exposure and vitamin D. And those are basically 1, 2, and 3 simple things. And then the only other I recommend to everyone from my more recent experiences is looking into some of the, again, what might be considered more woo-woo, but there's actually quite a lot of evidence behind it as well. The things we can do to actually cultivate our inner light, which is what I believe those biophotons these researchers were discovering before in primitive experiments we're finding. Things like for example, Dr. Joe Dispenza, Dr. Bruce Lipton, their work on how to improve the quality of our basically energetic system internally. And that's something I'm no expert in by any means, but I believe that is equally as necessary, if not more necessary, but probably equally as altering our external environment so that people can really achieve like lasting long-term success. Because if you get everything right outside, but you're still blocked and congested and traumatized internally, you might have trouble making progress.
Yeah.
As I have experienced, and I'm sure many others have and will.
Mm-hmm. Well, Matt, thank you so much for coming on the show. This was a lot of fun. I really enjoyed this chat.
Yeah, likewise.
And if somebody wants to follow your work, where's the best place to follow you?
Just right now on Instagram, The Light Diet. That would be the best. And then, that's pretty much it. People can check out my company if they want, and that's the best way to go.
Awesome. Thank you, Matt. Really appreciate the time, and hope to chat again soon.
Awesome. Thank you, Ari.
Hey there, this is Ari again. One more quick thing before you go. Just make sure to subscribe to our YouTube channel, The Energy Blueprint, and also make sure to subscribe to this podcast on your favorite podcast platform, whether that's iTunes or Stitcher or anything else. I hope you guys enjoyed this interview, and I will see you again next week.